Well, that was my Batman voice, in case you're a Batman fan. But anyway, we have section 2.4 here. So, good morning, afternoon, evening, whatever time of day you're watching this video. We're going to work through section 2.4. We're going to try and do it quick, and we're going to cover these two goals. So please get out your goal sheet and write down these two goals. The two goals would be to solve equations with variables on both sides, and that's what we're going to do today. And tomorrow we're going to do the second half of it, where we're going to identify equations that are identities or have no solution. That's what we'll talk about tomorrow, the second part of 2.4. So if you would like to write, this is our 2.4a, our first part of this. So if you look at this equation, I just want to know, it says, what's the solution to this equation here? It says 5x plus 2 equals 2x plus 14. What do you notice anything different about this equation from what we've been doing so far? Well, hopefully you notice that there's variable terms on both sides of the equation. So now we're going to work with equations that have variables on both sides. There will be multi-steps, and we're going to talk about what those steps would be to solve an equation like this. So why don't we do that? Very similar to others, we're kind of just adding another step to it, kind of similar to the steps we did yesterday, which is regular multi-step equations, or but solving multi-step equations with variables on both sides, our step one is to simplify both sides. So if there's any distributing or combining like terms, just like last time, if there's any distributing or combining like terms on either side, you will do that first. If not, you can skip that step. Step two, we're going to use inverse operations to move the variable terms to the same side. We want to get the variables all on one side, so we're going to get rid of them on the other side. And we're getting rid of the whole term, so we're actually going to be using addition or subtraction, not just getting rid of the coefficient. So we're going to use addition or subtraction to move one term away from one side. Try to get it so that you'd have a positive variable term on whichever side it's ending up on. So that's something you want to think about. After that, we're going to use inverse operations to move the constant terms. That would be the number terms that's a number without variables, it's just a number. The constant terms to the opposite side using addition or subtraction. So we want them to the opposite side of the variables. And then it should be down to a one-step equation. Just solving using either multiplication or division, unless we already have a coefficient of 1. But we'll just use multiplication or division to undo that last. Typically it'll be division to undo that last one, and then check your solution by plugging back into the original equation. So we are going to go through. Now make sure you have these steps written down, so you can just follow them. You can use it as a checklist until you get used to doing it on your own. But these two problems I'd like you to do along. For the first one, I would like you to at least watch. The second one, I'd like you to at least write down, if nothing else. And then I'm going to have a couple for you to do on your own. So this first one, let's look back. Our first step is to simplify both sides. So let's see. Is there anything we can combine or distribute over here? Nope. Over here? Nope. They're different terms. So we're good there. So let's check off number one. Number two, use inverse operations to move the variable terms to the same side. So we have variables over here, we have variables over here. We're going to get them to the same side, and if possible, we want to keep it as a positive variable term. So I think I'm going to subtract this 2x, get rid of it on the right side, so that that's gone over here. And what I have to do then is do the same thing to the left side of the equation. If this is our wall, we're going to have to do everything to both sides of the wall. So that would leave us with 3x here, still as the plus 2 equals our positive 14. So that would be getting the variable term to one side. Now it says use inverse operations to move the constant or the number terms to the other side. So this will be again addition or subtraction. So we do have a constant term on the side with the variable, so we're going to get rid of that by subtracting 2. We'll do that to the other side of the wall as well. And this goes away because positive 2 minus 2 is 0. So we have 3x equals 14 minus 2 is 12. All right, done with step 3. Now we got to isolate the variable using multiplication or division. Looks like we're going to divide. This is multiplication, so we're going to divide by 3. Let's do that to the other side of the wall as well. And we have x equals 4. Now, I did ask you to check your solution. That would be we just did step 4. We still have to do step 5. So I'm going to plug in x for 4 for x. So 5 times 4 is our checking here. Plus 2. I want to know if that's equal to 2 times 4 plus 14. Excuse me. So let's do any multiplication first. This would be 20. This would be 8. 22, and then 8 plus 14 is 22. So that means we are happy. That is our solution. All right, so that is how we follow these steps. Again, once you get the variable terms to the same side, really we're just solving a two-step equation. So like here, this ended up being 3x plus 2 equals 14. Really, it's just a two-step equation then. All right, this one over here, which I'd like you to for sure write down, this example number 2. And yeah, we'll just do that so we have our space here. This one, you're going to notice there's a few, you actually have to do step 1 here, which would be to simplify both sides using either distributive property or combining like terms if possible. Here we have the distributive property, so we're going to have to use that distributive property. So we're going to distribute 2 to the 5x and 2 to the 1. So it'll be 2 times 5x. Keep the subtraction sign. Whoa. And then 2 times 1. And over here we're going to do 3 to both those things on the inside. So 3 times x. Keep the plus sign, and 3 times 11. So really that would be 10x minus 2 equals 3x plus 3. So there we go. Next step, there's no other simplifying we can do. Use inverse operations to move the variable term. So we want to get the variable term to one side again. So I'm going to try to make it a positive. We could minus 10x over here, but then we'd have a negative over here. So we're going to instead get rid of this 3x over here by subtracting. I'll draw this wall again. So we have to subtract it from this side as well. So the reason I line it up with the x's, you could line it up over here if you wanted, but you can only subtract the 3x from the 10x because those are the like terms. So we'll just line it up with the x terms. So we have 7x total over here with that minus 2 equals positive 3. Now you have a two-step equation, just like we've done previously. Oh, sorry, this is a 33. So we're going to isolate the variable by getting rid of this constant term to this side. So add 2, so that goes away, and then we have 35 right here equals 7x is left. And then our last step would be to divide by 7 on both sides to get rid of that. So x equals 5. Now our last step is to check. And here's where, if you show me that it's plugged in, then you can check it on a calculator potentially. That would be okay, because this is a lot. But we have 2 times 5 times 5 minus 1 equals 3 times 5 plus 11. So over here, parentheses first, this would be 3 times 16. Parentheses first, that's 25 minus 1, which is 24 times 2. So this is 48. And that is also 48 if you would, sorry, 48. You would check what 16 times 2 is. So that means we are happy. That is our solution. All right. Following these steps, it's a sure-proof plan. We're just adding an extra step, really, from what our multi-step equations are, and that would be to make sure we get the variable terms on the same side before we do these other operations down here. So here's two that I'd like you to do on your own and have prepared for next time we come to class. Remember, like this first one, doesn't look like there's anything we can simplify on either side, but make sure you get the variable term off of one side so that they're all on just one side, the other side to start. This number 2, you might have to do some distributing here. So hint, hint, distribute when you do this one. I'd like to check these two problems when you come to class, so be prepared with them. All right, so until next time, thanks for watching.